of a pit or a big septic tank. All right. Natural gas plumbing delivers the fuel to gas burning cooktops, furnaces, water heaters, and clothes dryers, right? So these might be ways how you utilize your now in terms of clothes drying. This is really on an industrial scale where you have your large laundry facilities, right, where they use a lot of drying, right, using gas, right. So, but rather than piping these from the companies, as in certain countries, we actually have a natural gas tank on locations a lot of time in some of these facilities, and then these are actually refilled from trucks, right? So they'll truck LPG to the location, and then they'll utilize it in terms of burning to produce heat, right? Um, the water supply system, a building's water supply route, right? Give me a second. All right. Sorry about that. From the street, we are saying that in our facilities, we really talk about NWC routing our water supplies to our homes, right, or the street in front of from the meter to our premises. We are really responsible for that portion, right? So from the utility company, all right, to your meter on the premises, these are really considered to be the utility company's equipment, right? Such as your water meter is not your water meter, right? The valve before the water meter, if you have a valve before your water meter, all of this is considered to be owned by the utility company, right? Your part of the installation is where you connect beyond the meter, right? And you will provide, make connections to the different systems in your house, such as your faucets, showers, toilets, etc., right? Washing machine, water heaters, and so forth. This is your part of the equipment. Now, this is actually showing you underground supply where you'd have your boundary water. This is underground water main. They'll tap into the water main, come to your turn off valve, right? So right here they'll have your turn off valve, and then they'll have your beyond your turn off valve is going to be your meter, right? So they'll come to your meter. Now this is really giving you an example of the depth at which you need to bury your pipes. A lot of time when you go to facilities and so forth, you realize if it's not properly done, you're actually seeing your underground piping systems. You should not be able to see your underground piping system. Now, depending on the size of the facility, will also determine the size main that you use, right? Coming into the facility. So if we're talking about a large facility, they might use a 1 inch pipe, right? Or they might use an inch and a half pipe. And these are pressure pipe. Now we're talking about a drip pipe different from that of a pressure pipe, or the pressure pipe is a system, an airtight system, which will actually exert a certain pressure to be able to pump water to the different locations, right? Um, so this is really showing you a valve. This symbol is actually showing you a valve, and you are showing your connection to your home here. All right, give me a second again. Sorry about that, guys. All right. So we should have a good understanding of what this system or the layout of this system looks like, right? Oh, a close view of the system, your water meter, your valve will look like this, right? This is your, you would have your input valve from your main. So this is your main shut off. So if there's an issue with your water meter, the utility company should be able to turn off or isolate your meter. Then you will have your digital meter here, and then you will have your lock off or valve to your home, right? So this will actually turn off your main. I would try to use these type of galvanized um, lock off for your input. So rather than in your home when you probably have PVC valves, or they are not as reliable. However, these galvanized valves are able to work on, so you are able to change the washers in them, you're able to buy the spindle with the lock off, and so on, right? Another thing that I need to understand is that a lot of times they'll use unions for this valve you'll have a union. So if they are able to remove the meter without have to cut the pipes, right? Sometimes they just install it straight from the shutter meter for the shut off. All right, so it depends, guys, on the plumber or the configuration that they want to use. I prefer to use, and most plumber will prefer to use the unions, but because of the cost, persons will not tend to want to buy them, right? We have galvanized union and we have PVC union, right? Anything you can get in galvanized, you can get it replicated in PVC type material, right? The galvanized pipe, there are advantages and there are disadvantages. Same thing with PVC, you have advantages and you have disadvantages, right? The main disadvantage why we had chosen a couple years ago to move away from your galvanized pipes to your PVC pipes in terms of rust, right? Because after a period of time, because of the water and the chlorine in the water, your pipes will start to rust, right? Compared to that of your PVC. But with the PVC, after a period of time, if the PVC is not properly buried and exposed constantly to the sun, it becomes crystallized and then it bursts and start to leak, right? So they both have its advantage and its disadvantage. All right, the equipment for this delivery and distribution is essentially a system of water pipes, fittings, service valves, and faucets, right? This is the portable water we're talking about. These pipes and other fittings are commonly made of plastic, copper, or galvanized iron, right? The pipes range in diameter from half inch to 4 inches or more, right? So for your
Sir,
typical, yes.
I have to cut you, but someone said they're in the waiting room.
And don't see it pop up, you know.
Oh,
I don't see
I'll
it.
tell them.
Tell them to try again. I don't see anything pop up to say they are in the waiting
All right, sir.
room. All right. So now for your typical home or your typical facility, size facility, you would need half inch. Now, if it's a case where the facility is large, your incoming pipes can be up to 1 inch and an inch and a half, and then what they do is reduce it. So they'll use a reducer bushing to reduce it to the half inch to take to the different locations, right? And this actually improves the water pressure of the facility, right? For the different locations. So if you were to bring in a small pipe and then tee off to many locations, what will happen is that if you have more than one location using the water at the same time, then you would have a significant drop in pressure. While if the main was larger and you have smaller pipes teeing off to your utilization points, then the drop in pressure, right, with simultaneous use would not be as significant, be much smaller. All right, here, this is really a distribution in a large facility, right? So you'll have the tank, storage tank, because of the unreliability of water supply these days, right? And this is really mainly due to storage. Now, this is where our part come in, because all of these control mechanisms, such as your booster pump and your control down here, whether it be a automatic control system, right, and or a manual control system, all of this will be where your electrical expertise will come into play. Now here we have our pump transfer, actually pressure, right? So it's pressurizing the pipe that is the riser pipe that is into the roof, right? And rather than having a free flow, so this might be to another section of the building, what they do is actually put a booster pump to actually add to the pressure or build up the pressure in the exit pipe here. And then this is actually a free flow to these meters, right? So have your storage tank. A lot of the time these are now your PVC black Rhino tanks locally, right? They are actually coming in gray and blue, right? So we have them in different colors compared to one time when we are only able to get them in black, right? These are actually designed to keep your water sterile for a period of time. Now, the thing, disadvantage of having this as only a storage. So this is a utilization storage, meaning there is no pipe water from your transfer pump directly to your meters, right? Rather, we have it transferred to a storage tank and then to the meter. Now, the advantage of this type of connection is that when water goes, if you have a large enough capacity, storage capacity, right, you will not know until it comes back, right, until this storage facility run out, right, meaning there's no more water in the tank. However, and it keeps the water fresh in this case. Now, in the other case, the drawback to this, if it was piped and this was only being used for storage in terms of an outage, then what will happen is that the water will sit in the tank here until you need it, right? So the water will not be as fresh as the system that passes through the tank. Now, what will happen is that this is really going to be controlled by a bypass valve, right? So in one instance, the bypass valve will be closed, and the other instance, the bypass valve will be open, right? And it also can be configured to work automatically using flow switches and also solenoid valves, right? So we can actually configure this system. Again, it comes down to cost, because if you don't have the money to install the system, then you have to go with manual system. When your water gone, you have to go there and turn the valve manually, right? And then you have to go and close it manually when water comes back, right? So there are advantages and disadvantages associated with the cost of the system. All right, your drain waste vent system, right? Though it is one of the most glamorous, isn't one of the most glamorous parts of the piping, the drain vent or DWV system is one of the most crucial, meaning if you don't have something to take away the waste, you will have this foul smell in your home and in your offices, all right, and at your plant for long periods of time, right, and which is really detrimental to our health, right? So this system is basically, to me, more important than the potable water, in that if this system come in contact with the potable water, then we have contamination. So this system should be properly designed and run through the facility, right? And the job of the drain waste part of the system is to carry wastewater sewage to the septic tank. Give me a minute, my guys. Give me a minute. All right, sorry about that. So we are saying that this is really job is to just take away waste from your system to your septic tank or to your pit, right? Or the public sewer system. So this is your typical drain waste system. So I show it here in blue, but it's not colored blue in buildings, right? Blue is actually potable water. But for this particular illustration, we want to identify the drain vent system here. That we have our drain, our face basin, faucet, and kitchen, and so forth. Right, to realize that there is a system here. This U system, right, or this trap, the trap going back for so the scent cannot go back into the outside. Same way with here, right? It's able to trap water. Now for the toilet itself, right? The water that settles in the toilet is actually that what traps is used to trap the scent within the system. Also, there is such a thing known as bowl wax, which is placed around the opening where the toilet fits on the ground to prevent scent again from leaving the system to your facility, right? And we also have our traps here on your the system. And some of your traps here. Now, these traps can either be fabricated or you can actually buy a manufactured trap, right? So you can make the trap or you can buy a ready-made trap at the hardware. Now the trap is made using your elbows, 90-degree elbows, to create a U, right? That is used to hold the water. All right. The vent system. Now, the part of the plumbing that is usually less well known to most customers, we call it the vent system. So a lot of time persons don't realize that it's there, right? It plays a critical part. This system is connected to the drain waste pipe, right? And its job is to ventilate the sewage gas so they don't build up in the house or the facility. And the vent system also helps drain pipes maintain the right pressure for proper drainage. Meaning, if you were to have a closed system, right, a lot of time you are going to have build-up of gases, and then this build-up of gases can cause the system to become clogged, right? So when you are, for instance, you go to the bathroom and flush your toilet, and the build-up of gas will not cause that water to actually flow the system properly, right? So it will actually build up, because remember your pit, right, is also closed, and all these are closed devices. And then what will happen if you have a closed system or you keep on trying to put um, um, here into the system, right? What will happen is that it will reach a point that it will take no more, right? At that point, the system will become clogged and will start to clog up in the line, and then you have to call the plumber, right? And then he'll tell you that you need to put in a drain system. At this point, they'll charge you some money to make the necessary modifications, all right? Um, the pipes of the DWV system are usually out of sight, hidden in walls, beneath floors, and in the attic. But when the system ceases to do its job properly, it is hardly out of mind. Clogged drains are among the most common problems that occur in a DWV system, right? So most of the time, you not even know where a drain pipe run, what they're saying, until it's clogged, right? When it clogged is when you need to, you actually find out where this system go, right? And then you have to call the plumber, and then you have to use their equipment to clear the clogs and so forth in the system. Now, even the slope of the pipe is very critical when we talk about the drain vent system, right? The slope of the pipe, very critical. If the pipe is not sloped properly, what will happen is that you'll have a lot of build-up, right, of pressure, right, and it will not run off properly. Or, for instance, when we're talking about your toilet pipes, right, this liquid will run left the solid, and then you'll have a build-up in the pipe and a clogged pipe, right? Sometimes pipes can become clogged due to vegetation, such as root. When you have a plant root, I went to a facility one time. I took a plumber there, and when he was able to identify what was happening, is that a root had grown and bored through the 4-inch pipe, right, and caused the system to become clogged, right? So we had to cut it out, and actually it took a lot of work to find it, right? You have to rod the line and where the line lock up, and not going any further. Then you have to measure off. First of all, you have to find where the line run and all of that, right? So this is why plumbers normally charge a lot of money, because then they have to interact. And most of the time, the drinkable water is not a problem, but the drain system, and they have to interact with all of this waste, so they tend to charge some money, right? So it's always good to do it properly, or to set up the system properly in the beginning. All right. Here I'll show you a typical layout of what is happening. We have our this dishwasher supply, dish supply. A lot of time we'll not find this in our typical household. So if we're talking about your sink, right, what you'll have your water supply line. So these are here, right, your hot water and your cold water supply line. You'll have your drain here, right, you'll have your trap. So this is what I'm talking about. What will happen is that you'll have water settled up to this point across here, right, when you, because of the difference in height, when new water goes down the drain, it will push out what is here and push it into the drain system, all right? And so it will always have, no, the thing you need to understand is that if this is not used in a long period of time, then you expect the water that settles here to evaporate after a period of time, right? So it's not foolproof from smell, but if it's in daily use or weekly use, then we don't have evaporation happening that fast to leave the trap empty. No, this trap, can anybody tell me what this trap is? You have the traps have different names. You know, this trap is what? For anybody who understand plumbing systems. What type of trap is this I'm pointing on here? Anybody? The trap here, what is it? So this is the trap. Let me bring up the chat. I think somebody just put it in the trap. Oh no, sir, you don't know what it is. You really tell me so what a class of 26 persons present. No, you don't know what this trap name. No. All right. So this trap is known as a P trap. Right. So it's a P trap. No, why they call it a P trap is because if you were to close, all right, if you were to spin this part, what will happen? Let me write it down here. So it's a 3P trap. And if you were to, now the trap is like this, right? But because of this joint here, if you were to actually, no, it's not a J trap, it's a P trap, right? If you were to spin this part here, if you go to the store, that's what they're going to sell you, a P trap, right? If you spin the part that is here, it can be turned and put this way, right? So this can be turned to angle into the direction that you want it to be, right? They don't use this part because the trap ends here, right? They don't use, the trap is entirely here. From this point to this point is a trap, so they don't call it a J trap, they call it a P trap. No, another type of trap that is used is your S trap, right? So you have your P trap and your S trap. Now the P trap is used in instances where the drain is coming from the wall, right? When the drain is coming from the wall, we utilize our P trap. When it's coming from the floor, you use your S trap, right? So your P trap from the wall, your S trap is when it is going into the floor. So your S trap will look like this, and it will come like this, and then it will go down like this to the floor, right? So that is basically your S trap, and you have your P trap, all right? So these are your the different type of traps that you will use. And then somebody tell me the mounting height of your trap. Well, the connection in your wall here, your drain connection from the floor, your typical mounting height. And what is? No? Think
2
about
feet.
it. 2 feet. All right. So the mounting height of the trap from the floor is 2 feet, right? That is to allow flexing of the joints to relieve strain. So you don't want a lot of strain on these joints. A lot of strain on the joints will cause leaking, right? So you want it to be the transition to be smooth, right? Because there's no what is known as tread tape here, no PVC cement here. It's just a washer, a plastic washer here, and a plastic washer here, right? And remember, this system don't keep any pressure, right? Because of the vent pipe. So there's no pressure in the drain system, so you don't need to have any what is known as PVC cement, or other persons don't know it as Tangit. Tangit is just a brand, guys. Please do not write it on any assessment if I ask you about it and give it to me, right? It's actually PVC cement, good, or PVC adhesive. So Tangit is a brand, right? So because Tangit was one of the first brand, persons tend to call the thing Tangit. Even myself, when I go to the order, I ask a Tangit. Scientific and teaching purposes, it's a PVC cement. All right. All right. So this is basically a close-up view now of your system. So we have our trap here. All right. We have our shutoff valve, our angle valve. So if you go to the store and ask for angle valve, they know exactly what they're asking for. If you go and ask for a shutoff valve, you have to go describe the type of shutoff valve you want, right? So in essence, if you're ordering this from the store, you need to say a angle valve. That's what it's term, right? And you have your flex hose or your flex tube, right? The flex hose, right, is more recent. It's more being used compared to that of your flex tube. The flex tube is a gray one. So like for older type installations, you will say the flex tube, but for newer type installation, because the flex tubes always burst after a period of time. Then the plumbers now are gravitating to using or are using the flex hose much more, right? So they come in measurements of from 12 inches up to about 20 inches, right? So you will get these flex hose from 12 inches up to 20 inches in length, right? And you see another one here. This is really for your hot water. So you have your cold water angle valve, and you have here, and the same angle valve for hot water because it's made of metal. Now, however, when we're talking about your hot water system, the pipe used for the hot water system is different from the pipe used for your cold water system. Now, for cold water system, you would want to use the regular PVC pipe, right? For your hot water system, you'll use your UPVC pipes, right? So these are really for applications where the temperature is going to move beyond your regular potable water temperatures, right? Now, so if that is the case and you go into your shower, right? And let me draw it right here. So we have our shower here, right? We have our shutoff valve somewhere here. So in our shower, we have our mixer here for persons who have hot water, and you have your shower here, you have an elbow here. So you will find an elbow here, and you will have two pipes, a hot water pipe and a cold water pipe. So we have our cold water and hot water. So C and H. Now, can anybody tell me which pipe they'll use from this valve here, which is a mixer, known as a mixer in your house because it mixes your hot and cold water? Which type of pipe they'll use from here to this fitting here? Anybody? So what's the name of this pipe here? What type of pipe? Is it your regular PVC pipe or your
UPVC, sir?
UPVC, all right? So you will not use your regular pipe here because after a period of time, then this will become deformed, right? So in a properly pipe system, this will be your UPVC. And what type of fitting will this be? PVC or galvanized? Which one? Why not UPVC? Why not UPVC in here? Because you could use UPVC, you know, but why the plumber would prefer to use this one?
Because it can expand contract with the...
Good. Perfect. Perfect. Right? So we are saying that if we were to use this, after a period of time, the threading will go, then you have to dig out a bathroom or whatever. If it's a shower that is frequently used, like in a shower room for a gym, then after a time the threading here will be damaged because of the expansion and contraction of the fitting, and then it will burst, and then you have to dig out the wall, while this now being galvanized is able to handle the expansion and contraction based on the hot water coming out or lukewarm water. All right, so understanding these things are very critical when we talk about plumbing systems, right? It's not as simple as just getting some pipe and doing something in your home, right? But now that you have gone through this course, you should be able to get some pipe, something at home and do the proper thing, right? All right. So that's basically it for now, this slide. Let me go to your next slide. We will take us to our escalators. All right, before we go to escalators, can anybody tell me the typical mounting height of these, all of these fittings, such as the sink tops, your bathroom extras in terms of the top, right? The sink, the kitchen sink, all of these are other devices. Anybody know the typical mountain height point. Anybody before we move on? This is beside what we're doing, you know, but you should have an understanding so that when you go home, right, or if you are at home now, you will know if this is too high, right, or if it is too low. Now, the typical height for mountain utilization surfaces is 3 feet, right? So your countertops at home is going to be this. This should be your maximum working height, right? Your kitchen and sink should be here as well. Your bathroom fixtures, here your sink should be actually 3 feet as well. Anybody know the distance of drain pipe on the wall? So this is your toilet drain pipe, right? And this is your wall here, and there's a distance, right, from here to here. Anybody know what this distance should be? So this is your wall. All right, so distance to the center is 12 inches, and if you're using a 4-inch pipe, so this will depend on the pipe. No, the pipe to the center will not change, but distance from the wall to the pipe will change depending on the size of the pipe. If you are using a 4-inch pipe, remember you are going to have 2 inches here, right? So it should be 10 inches. If you are using a 3-inch pipe, this is going to be from the 9.5 or 10.5 from the wall, right? So depending on the size pipe. Now, for your downstairs pipes, drain pipes that will carry sewage, these are typically 4-inch, right? Can anybody tell me the size of the pipe for your upstairs or different floors on the ground floor in any facility? So if you're
I thought that the toilet waste pipe?
yes, the sewage waste pipe.
3 inches.
3 inches, golden sulfurator. All right, so any floor other than the ground floor, you are going to be using 3-inch pipe, right? And for the ground floor, you will be using 4-inch pipe, right? The reason being is that this 3-inch pipe is going to be feeding into this 4-inch pipe. So you want this pipe to be on the capacity of what is coming from the 3-inch pipe, right? So it's standard to use 4-inch as your ground level sewage pipes and 3-inch as your upper floors sewage pipe. All right. So that's really a rundown of what this system will look like. All right, let's move on to our escalators, right? So robot the slide and let us move on to our escalators. Now, escalators, what are they, right? These are really devices, right? Mechanical devices that transfer persons or things or equipment, but mainly person from one level to the next level in a facility, right? So a lot of times these are really employed in malls, right? You'll find them a lot being used in malls, right? And the picture shown here shows you the typical components of an escalator system, right? So you have your on-rail assembly, right? We have the on-rail. So this is really the motors that will drive. So you realize that it's built off from the main motor to drive the on-rail, because they want the on-rail to turn at the same speed as the steps, right? As well as they want everything. So this motor is your main motor, and these are basically your assemblies that will transfer the motion from the motor to your handrail and to your steps, right? We have the steps shown here, We have the rollers. This is what the steps will roll on or move on. Right? So you have your guide rails, such as to not to run your rollers, right? And we have the step chains that will actually move along with the step to create the step in motion, right? So it's flat here, then it come on and create your step in motion. We have our lower sprocket, and this is our upper sprocket assembly. All right, so these are basically now. So our job as electrical persons will really is to the control mechanisms again, right? But because of the versatility of our engineering field, right, being that employees wanted to know of aspect of majority of the systems, then we need to look at the other aspects of the system. Now you would have already known about all of the how to connect your motor, how to determine your rotation and all of that, right? But now you need to tie it in with your mechanical system. Now, so we're going to look at the different parts, right? The moving staircase used as transportation between floor or levels in subways, buildings, and other mass pedestrian areas. So this is basically a rundown of what an escalator is, right? It's different than the elevator, right? And it's basically a moving staircase, right? It consists of a motor driven chain of individual link steps on a track with cycle and a pair of tracks which keep them horizontal, right? So it's basically the movement is basically uniform because you don't want anybody to fall. So it's not a case that when you step on a step and you start to move and you reach the center or the descent or the ascent, then it starts to move faster. No, it's cycled, it's constant, right? So it will move at constant speed to allow you to easily access it and to allow you ease of to get off, right, at the top or at the lower end of the steps. Now, escalators are used around the world in places where lifts would be impractical, because it would be impractical to have a lift that will move from one floor to the next, right? A lot of time, and these are mainly employed in first world countries. We do have them in developing countries, but in larger malls and so forth, we have a lot of people moving. They will have the physical steps and they will have the escalators for fast moving access, like for persons that will want to move fast, right? They'll have them. Although I think it's much faster to use the manuals and the regular steps, but persons tend to want to use the escalator once it's there. Now, why persons would not want to have an escalator is the added cost, because all of this is going to be, you have to utilize electricity, right? So the added cost is going to be your electric charge, setting up your electricity bill, right, and the maintenance cost. So all this you'll have to factor in. So if you were building a mall, right, so and for the guy hear a lot of knocking, guys, because they're doing some construction next door to me, right? I'm unable to block out that knocking. So that will play a part, right? So the maintenance factor, right? If you don't have an in-house maintenance team, you probably have to contract a firm to do it, or you call them or you put them on a maintenance contract. It's going to be added cost in terms of utility, right? And it's going to be added cost in terms of parts and repairs when it comes to the maintenance of the machine, right? So in terms of breakdown, you'd possibly need parts. Now, the decision that you have to make as an operator for one of these installers is whether to have a in-house stock, or you're going to purchase when it breaks down. The disadvantage is that if you were to purchase it break down, you have to consider the lead time in getting the parts that you need, right? So we'll give you some principal areas where they are utilized, right? We talk about department stores, shopping malls, airports, transit systems, convention centers, hotels, arenas, stadium, public buildings, right? All of these areas you can utilize your escalators, and it will play a vital role and a critical role, right? Now, when we're talking about these days where you have to have easy access for persons of disability, in the case where the persons can walk, but they have difficulty walking, then these elevators, the slow ones, because you have fast one, you have one jump faster than some, right? Then it might aid in their ascent and descent, right? All right. Modern escalators usually incline at a 30-degree and is limited to a rise of 60 feet or 18 meters. So you'll not find an escalator going higher than 60 feet with floor-to-floor rise of about 12 feet, right? Or 3.5 meters. So you'll not find an escalator going beyond. These are standard measurements that they'll use to in these escalators, right? Anything greater than 30 will be too steep. Even when you're talking about your design are designed to give you a descent on say 30 degrees, right? So it will be similar to that of your manual step. They move at a rate of 0.3 to 0.6 meters per second. And they move really slow, right? And this is to allow persons to actually get on and get off of escalators, right? Landing platforms, right? The components. Landing platforms are the two platforms at the two ends, right? That holds the curved section of the trucks, as well as the gears and motors that drive the stairs, right? So we have our lower landing platform and we have our upper landing platform. The top platform usually contains a motor assembly and the main drive gear, while the bottom holds a return gear that will, is really just a gear, and you have your rail and your chain link on the that gear, right? So your main motor, 90% of the times, will be in on the top or under the top landing platform. All right. Now the truss. The trusses. So we're just going over some typical components. Escalators can be as sophisticated as you want them, and they might and can be as simple as you want them. But these components that I'm telling you about is going to be your typical components, right? So you have your truss, right? Is a hollow metal structure that bridges the lower and upper landings, right? Composed of two side sections joined together with cross brace across the bottom and just below the top, right? So if you just remember that image that we had first, right? Your truss is really the assembly, the real assembly at either side of the step, right? The ends of the truss are attached to the top and the bottom landing platforms via steel or concrete support, right? We have a balustrade. The balustrade is composed of handrails, balustrade panels, and skirt panels, right? And you have your handrail. The handrail is really provides a handhold for passengers while they are riding the escalator. However, not all persons use the handrail, right? But you're advised to do so because of safety reasons. All right, the balustrade panel is made of either metal, sandwich panel, or right. The balustrade panel supports the handrails on the escalator, right? So there really is the device that actually the handrails run on, right? The skirt panel is really the bottom of at the bottom of the balustrade is called a skirt panel, which actually hides the assembly under the handrail, right? It is notorious in this art for being a frequent site of injuries, right, and failures due to possible entrapment of material, such as body parts, including body parts in the machinery, right? So if you want to see what I'm talking about, when you go to the supermarket and you look at the conveyor belt for the cashiers, you tend to have the section that transition between your conveyor belt and the scanning section, or the section that they're going to send the food along, right? That transition is similar to what we are talking about with the skirt panel, right? So that transition actually prevents what you buy in the supermarket from falling off the conveyor through the little space or becoming stuck through the spaces, right? Same thing with the panel skirting. However, if it is not properly maintained, it can cause injury to occur, right? So you have to properly maintain it. Now the truck system is built into the truss and to guide the steps, right? Which continuously pulls the steps from the bottom of the platform back to the top of the in an endless loop, right? So it's always better to pull it up than to push it down and then it get out of control in terms of speed and then thing. But it's easier to pull up, right? We have better control over the pulling, right, than going down. All right. The steps themselves are solid, one piece, decast aluminum or steel, right? So these are really what they are made of. All right, so we move on to our elevator. So escalators, we don't see them much, but elevators, basically, a lot of us use them in our daily activities. Now, what are these classified as? We have many different types of elevators, right? We have elevators that are external to the building. We have elevators that are internal to the building. We have dedicated elevators and so on. Many different types. So we're going to look at some basics of elevator, right? Elevator is defined as a permanent lifting equipment serving two or more landing levels, right? Unlike elevator that will serve one landing level from one to the next, the elevator will serve multiple or can serve multiple landing levels, right? It including a car for transportation of passengers, right, or other loads. What I mean by other loads, you can have an elevator that only that is used to transport machinery and so forth, which is more of an heavy-duty type elevator, and then you have your regular passenger elevator, right? Elevators began as a simple rope or chain hoist, right? So when you're watching those long time shows that show you the castle, this is really where elevators are to lift things over the castle wall, right? So that's basically how it started out. Now, an elevator is essentially a platform that is either pull or push up on a mechanical means, right? In time past, and in modern, there is such a device on it known as your counterweight, right? All elevators will have a counterweight, right? So, no matter how modern elevator system becomes, something fundamental to this type of system, right? A modern elevator, the elevator consists of a cab, also called a cage or car, mounted on a platform within an enclosed space called a shaft, right? So the elevator shaft or hoistway. Now, in the past, elevator drive mechanisms were powered by steam or water hydraulic pistons, but today they are powered by motor-driven circuits, right? So of what the the components of our typical or basic elevator will look like, right? This is the building, right? You probably a maintenance house here, or it can be open to the atmosphere like this. You have your controller, right, which is housed there. Right? You have a oiling machine, which is really your motor. You have the sling assembly, right? Deflector sheave, speed governor to govern the motor, right? Safe ties, guide rails, and the cab, right? Traveling cables that are these that will ice the elevator and so forth. Switches that will create this logic, buffers, counterweight, and compensating sleeves. All right, so we're going to look at all of this, or some of them in the different equipment in brief. Now, before we can do that, we look at the different types of elevators, right? We have a hybrid type elevator, we have the drum type elevator, we have the traction type elevator. What are these, right? The name don't mean not much. No. So this will give you an idea of what the elevator is. Now, the hydraulic type is similar to that. Really a jack lifting a cab, right? So the hydraulic elevator is really a jack lifting a cab. Now, the mechanism, the plunger pushes the elevator car up as the cylinders fill with oil, right? Gravity lowers the elevator or the car when the oil from the cylinder is let out, right? So this is your hydraulic type elevator. Disadvantage of this type of elevator is that it has to have deep pit, because if we're talking about the ground floor, it should be able to fit the lifting equipment in a pit in order to reach in level with the floor, right? So you would have to have it. And the travel distance of the car is limited, so these are normally used for tour and drilling, right? Because of the size lifting hydraulic lifts to be required, right? Normally these are used as cargo type elevators, right? So these are used for cargo, lifting car from one floor to a next, right? Advantage of hydraulic elevator is cheaper to build than the other elevator types because they don't need all of that sophisticated control. All right, is used mainly for lifting very heavy loads for short distances, right? So like freight elevators. All right, we have a drum type elevator, right? So it looks more and more like what we are used to. Now the drum type elevator, in terms of mechanism, it contains a steel drum, right? Powered by electric motor or steam. So this is the motor here, and we have our steel drum. The icing rope is one around the steel drum, right? See it here shown in the picture, right? So it spins the drum, right? And then it will hoist the car and lower the car. The icing rope pulls the elevator car up when it is wound around the steel drum. As the hoisting rope unwinds, the elevator car descends. Now, the advantage of this type of system is that the maximum length of hoisting rope depends on the size of the drum, right, which affects the travel distance of the elevator car. So when you have a lot of floors, you then not want to use the drum type elevator, right? Heavy power is required to pull the weight of the elevator car, hoisting rope, passenger, and payload, right? Payload is whatever in the thing there, the weight of the car and thing put together. Now, the uses, this might find use in nowadays, because this are not used much nowadays. They usually use them in our buildings because of their disadvantages of not, because remember, as technology increases, right, we're talking about higher and higher buildings, right? And as the height of the buildings increase, the use of this type of elevator now becomes obsolete, right? So now we have to move to another more sophisticated type of elevator, which is our traction type elevator, right? Now this type of elevator is what is used a lot in right. We still have our mechanisms and so forth. We still have our in modern types, a counterweight is really used when we're talking about like free fall and so forth. Now, the hoisting ropes pass over a traction wheel, and is also counterweight on the car, right? So it's really similar to that of your medieval type, or I should say not medieval type, right? This was the first evolution of the modern type elevators, right? The counterweight really is used to balance the weight of the elevator car and off of the rated load, right? It provides friction on the traction sheave to stop the ropes from slipping, right? Meaning running off, or you have a runoff of the rope on the wheel. Now, the advantages of this type of elevator is that there is no limitation on the travel distance, as it is not dependent on the drum size. It saves energy and power, since due to the counterweight, the machinery does not need to pull the combined weight of the elevator, car, passengers, and payload. So even though you see the counterweight, it still have machinery, right? It is the most common elevator nowadays, right? We're going to show you the modern iteration of the counterweight type machine, or the traction type elevator, right? So this is basically how it looks, really a pictorial view of how the elevator system is, with the different floors and the door open, right? And we have our motorized, we have our counterweight here. So this is a small counterweight around here that is used to hold the cables on the traction and so forth, right? So here is really what is happening when we look at the force diagram, right? Power is transmitted by friction between the rope and the pulley, right? Because you have the weight of the car, you have the counterweight, which will hold the cable onto the pulley, right? The friction factor is greater than T1 divided by T2, so it's greater than this ratio to ensure enough friction for power transmission. Meaning, if this is not greater, then what will happen is you'll have slipping along the pulley. You don't want to have slipping along the pulley. You want it to have proper traction, right? And this slide formula is what they use to determine what this counterweight should be, all right? So these are really the different loading principle. You have the 1-to-1, you have the 2-to-1, right? You have the 4-to-1, right? Multiple roping reduces the suspended load on the machinery, right? While the rope speed gets increased, hence used for bigger car loads and lower car speed, right? So when we're talking about adding more load to the system, we're talking about using more ropes, which is in turn increasing the ratio of the system, right? This is our car and sling assembly, right? Where you have your slings at the side, you have your guide shoe, you have a car, and you have your safety gear. This is for free fall. What will happen is that it will lock in and slow speed of the car. Now, the car is a safe place to carry passengers. Overloading is not possible. Fluid is limited to the capacity of hoisting and safety equipment. What they are saying is that this type of elevator is so designed that once it only the persons can fit, it is able to carry them. Because look, you know, if you put a lot of slim persons in here, the weight of that slim person right? To do it of actually putting in larger persons in there, and you only can go less larger persons, right? So they're saying that it's very unlikely that this car will be overloaded. Now, around the car is a steel frame called the sling, right, which you know about, and the suspension ropes, guide shoes, and safety gear in the sling, right? So the elevator can move freely up and up. Now, your counterweight system, the counterweight is fixed to the other end of the suspension cables, right? And this is how your modern counterweight will look. Even though it looks like this, guys, it's very heavy, right? It moves in the opposite direction to the car. So if the car is going up, your counterweight will be going down. Its weight is same as car plus sling plus half the rated load, right? It ensures a friction between the ropes and the traction wheel. Good. Now the guide rails, this is really them inside the elevator. So if any of you are privy inside a shaft, the shaft of the elevator, a modern type elevator, these are what you'll see. You'll see your guide rails and all of that. So it's very difficult for the elevator to go from side to side, right? So the room is limited to the shaft housing. Now, guiders make the vertical part for the car and the counterweight. They are fixed to the walls of the shaft, right? So they are fixed to the walls to get the elevator up and down. All right, so we have come to the end of our slides for today. Next week, guys, we'll be looking at our HVAC systems. Now, the HVAC systems is going to be a little bit more involved than today. This is really just an introduction to your mechanical system as relates to your plumbing, escalators, and elevators, right? The HVAC system is more involved because it involves some amount of calculations to complete the unit, all right? So next week we'll be both utilizing both the lecture session for the Tuesday session and the Thursday tutorial. All right, so remember we don't have tutorial right after the class. It's too rough to have tutorial right after 2-hour class. Now, again, for persons who are late regarding the test, well, I start marking it. I can't finish mark almost 50 papers, right? It's a lot of reading. The multiple choice is marked on site, but I'll show you the grade until I finish the worded section for everybody, and then it will release the grades. All right. So I am hoping to complete marking by your next class, so that you can make your inquiries and so forth. Now, what I need to say to person, guys, if you had cut and paste, meaning the slides that you are given, if you go and cut whatever definition and paste it in the field in Moodle, and somebody else go and cut the same information and paste it, it is going to reflect on the system as plagiarism. Once it reflects on the system as plagiarism, the grade assigned is 0. Right? Everybody know how plagiarism works already, right? So if that is the case, right, you are going to have a lot of issues when it comes to the worded problem. Right away, as I go to it, I'm going to see the flag and it will assign 0 without me even start reading it, right? Now, the ones that don't show the flag going to come up for me to read, right, and I read and assign a grade. But again, if you did cut and paste, even if you did cut and paste from the net, yes?
Yeah, but something. I'm just saying that that was not the
No, you can't do that, Fred. You know that already. If you
I was saying that in relation to what is on the slide, we're going by what is on the slide. I never know that it will result in you.
Yeah,
Um,
all right. If I was marking the paper, meaning I print it and mark it, don't it? Say me read, say, I read that the boy run down the road. And I read on the next paper, the boy road. What is that saying to you, Delroy?
so you're saying that if both students are in an exam room, let us put aside the technology in a physical exam room and you write something from memory, right?
It's a bit
Yeah.
difficult to have it word to word sometimes.
No. You might not have all of it. Word for word. But let's say whether it's 30% or 40% of it, word for word, from the slide for that.
No,
those
it's
two
not
students.
sure about plagiarism. It does, understand what I'm just saying now. If the student go to the slide and cut, and somebody else go to that slide and cut the same information and paste, it is going to be what? Identical, and the system going to read it as plagiarism, because true and in fact that is cheating. Whether it was paper based or software based, if two persons give me the identical work, it is cheating. Correct? If it's a fact, I got what me lose here.
No, me just still look at it from what we just said to you.
Yeah.
That both of us can be in a physical exam room and submit something from memory. People memory sharp, right, than others, and person might just submit.
So friend, you're all first year, 4th years, you're about plagiarism from day one, don't it?
Yeah, but I know about plagiarism, sir. But if you're going to do something from memory, and write it from based on the notes,
No, but
it's not like an essay you're doing, and they ask you to, that when you're doing an essay or whatever, it would be in your own words. But if you're going to read the slide and decide you're going to give, I don't know, because some lecturers will ask when we was here doing, you have lecturers ask that they want exactly as though them give it to you. Like they want it verbatim. For example, Ali Shafi, Shafi Ali, he's one of them in particular who usually demand that of us.
Yeah.
Sometimes you don't even know what the university wants.
No, man, but if you read the university thing, it tells you if you work are identical. If you look on the policies in the university handbook that speaks to plagiarism, if work is identical, if two students giving an identical work, it is considered to be plagiarism. Right? Once the work is considered to be identical, it is considered to be plagiarism. Remember,
I think things need to be examined within context, though. But anyway, I'm not going to live at the point.
Yeah.
Sometimes things are interpreted, right? I think everything can't be general. It must be based on a situational thing. But,
I understand what you're saying, but in the context, student work is what you submit. It's still your work, what you submit. And we are saying that if it is identical, a lot of time, persons, remember, we're going to give an example in terms of finals. You don't see about your finals. Some of the time why some people feel might be just that them give somebody write the thing word for word, like how them get it from them slide or the source, and another person do the same thing, And when you review it, you realize that your grade not change. And you say, but I know I'm right what I'm supposed to write. I'm right. You understand? And then you can't justify in your mind your grade. But at the same time, even when you ask a review, it coming back as the same grade. Because a review is done by another lecturer, And then they're going to read the same thing and then go and pick up the same thing and then they're going is either they're going to change a grade, add more to it, or sometimes you even lose more when you go through a review. Right? So I always tell persons, try to be original when you're defining these things. It's not me set the system parameters, as I tell you. I just upload the test and open the test, and I set the open date and the close date for the test. The system parameters are set by the system, right? Like the plagiarism parameters and so forth. And once is what is considered plagiarism, right? So I think up to what 25% is not considered plagiarism, but beyond 25% is considered plagiarism. So it's not me said. So they give you allowance because they know it's going to be very difficult for you to write back something word for word. So there is allowance as it relates to plagiarism. But when we're talking about it going beyond the percentage, the system is going to pick it up as you having plagiarism. All right. So hopefully by next week you're able to get the test. I set a target date to finish by this Friday. I actually mark some every day, right? Because it's very difficult to sit on the computers for hours to read them. So I read a portion a day, and by Friday I should by next week's class. So by Friday I should be finished. By next week's class you should be able to see your grade. Alright, I set the multiple choice as simple as I could get. I couldn't get no simpler, right? So people will get 100 out of 100 in the multiple choice. I'll tell you, we're not killing nobody. No, that is a lot of information. It's just that I want to test you on how you materialize the information, how you interpret information, right? So the multiple choice was so designed to do that. A lot of the questions were designed by me. Some I get from books, but based on what I give you and what is provided to you and from regulation, right? So again, see you next week at 12. So we don't have any tutorial this week.